Hi folks, 2016 question C1 here. So in this one, the first thing I want to say to you is, if it's not a standard road, don't let it throw you, okay? The same things we've learned for doing, surface geometry in general definitely apply here, okay? So in the first thing we're told here is the cuts and the fill are at 1 is to 1. Now, usually we're used to scaling it up. And when I looked at this question the first time ever, I was a bit thrown for a second. I was thinking, hang on, these are only 1 meter intervals. So what am I going to be doing? If with a rise and a fall, we'll say 1 millimeter radius semicircles. Well, no. Don't forget there's a scale in this. And I missed it myself for a second when I first seen it. So a scale 1 is to 100. Okay. So, so the scales, that means then when we're stepping off, our things are going to be in tens, okay? So it's going to be 10 mil for a cut or 10 mil for a fill. Now, the first thing we've been asked to do there is to finish out this side of the pool here, okay? So we can come up here and we can mark it off in tens. So I can see here, if we're told in the question as well, this is all going to be 5 meters. So this is way too high and a bit of fill going on over here. So we'll just space them out first of all. So this is cuts, so it's going to be going upwards. 9. I'll do my cuts in red as usual. And we'll just mark them off there. That's going to be 5. Okay, over there, that's where it's going to turn from cut to fill again later on. And that's cut there. Next, we're moving into fill territory. So put down your compass. Okay, so if this is 5, this one is for 4, 3, and 2, and I don't need to go down to 1. So we'll mark them off there. So the 4, first of all, appears here, and here, 3, and 2 up there. And so that's fill. So that's part A done. Then part B down here is telling us DE is the edge of a sloping pathway. At D, the pathway is at an altitude of 5, so we'll mark that in, and E is at 4. And we're told that it's falling uniformly to E, okay? So using the same slopes above, show the earthwork cuts, which it is in this case, necessary to accommodate this pathway here, okay? So it's going to be cut at the butt, fill at the hill. This is the hill, this is the butt, so it's going to be cutting, so it's going at the butt there. So set your compass there to 10 mil. We'll draw a semicircle here. Then we put on our line, tapering away from the edge. We'll space these out in tens. And you can label them then if you want. 5, 6, 7, 8, 9. Numbers are always going upwards for a cut. And start marking them off there. That's 6. Over there as well. 7, 8, Then we can do it on our freehand curve then when you're ready. And that's part B done, okay? Just go back to the question there. Part C is saying at the southern end, the floor slab of the pool is sloping and is of uniform thickness, so it's the same thickness. R and S are 2 points on the floor and their altitudes are 4 meters and 3 meters respectively. A vertical borehole at S reveals the bottom surface of the pool has an altitude of 1.5 meters, okay? And the strike of the floor is 55 degrees east as indicated by the line L here, okay? So the strike of the floor is, that's our strike there, okay? Determine the dip and thickness of the floor. So same thing as we always do. When you have a strike there, we're going to look along it. Okay, and we're going to put in our XY line here. We're told S has a height of 3. We're told this guy R has a height of 4. And this is the dip, right? That angle there, if you're looking for it, which they are. And we're told, remember it said there when a borehole, a vertical borehole was drilled at S, it said that, and I'll just go back to the question there for a second, it said the floor slab has an altitude of 1.5 meters, okay? So, measuring up off the ground there, 1.5 meters. So what we're going to do there is, when you've that done, is you just mark that off, and we're going to draw in a parallel line there. And this will get us the thickness also, which is also asked for, okay? Last part there is telling us that in the question there, that it says part D, there are 4 entrance steps to the pool as shown. The top step is level at an altitude of 4.8. In the same space provided on the drawing, draw the vertical section profile through the steps and the floor slab along the line PS, which is going from here to here. Show the steps to be of equal height, okay? So they have the top step done in for us, okay? And that's at 4.8. Now we know R is at 4. We were given that a minute ago in part C of the question. So we'll just do a little line down for a moment. So if that's 4 steps, they're going to be 2 millimeters each. If it's going from 4.8 to 4. I'll just draw a few light lines there. Now Q is there, so Q comes out, drops down. The next guy as far as there, drops down, as far as there and drops down, and the last guy ends up at 4 there. So we'll just do the tops of the steps in heavy there. Now that will be R. S will be over here, but we know in this, from the last part C as well, it was at an altitude of 3 meters, so it's 10 mil down from that line there. And that will be S. And that'll be that question finished. So as I said, folks, if you come across a question like that and it's not a standard road, remember we had a golf course before, this time we have a swimming pool, don't let it throw you, folks. Same things apply. Okay, so hope you found that useful. Take care and stay safe.